Alright, today we're going to talk about JavaScript fundamentals. The last one that we talked about, we went briefly over functions and, well, more about expressions, operators, and simple
took it
stuff.
down to the barest of the bare bones, down to the values and the operators, and I think we touched on functions finally.
At the very last, yeah.
So our last video got pretty good response relative to anything we experienced, like 500 views on
Everybody
YouTube.
cheer.
And we got comments, so we're really pumped about this. We've also decided to make these a little more bite-sized, so hopefully we'll ramble less, and when we're done you'll have not a 45-minute video.
More 15 minutes is what we're shooting for.
So in the spirit of brevity, we're just going to really quick recap.
Here we go. You know what we can do to make this fast? I'll write down something here and you recap it. How's that?
Okay.
We're doing this on the cuff here.
It's like a cooking show, and I prepared this earlier.
So we could say, okay, we need to talk about values. What are values?
Okay, a value in JavaScript. I'm just going to write everything.
Yep, I'm going to write it and you explain it.
Okay, a value in JavaScript is the smallest piece of information. It's just a thing. Usually you'll see these as numbers. So a number or a string or a boolean like true or false. And there's a few others like the object literal is a value. I don't think we talked about literals. Objects, we did talk about objects.
Yes.
Those are values, okay. And then there are operators. Operators operate on values. These are like plus and minus and divide and multiply.
And then what's an expression?
And then expression is any sequence of values and operators that evaluate down to a value. So this is an expression. 2 plus 3 is an expression. This is also an expression. Let's see, 2 plus 3 times, times 14 divided by 2. This is an expression.
It's complex.
But sneakily, it's also a lot of expressions. There's an expression, how would this work?
Plus.
Here.
You could do that, I guess.
And then here. And then there. So there's 3 expressions all dangled up into that.
So you're saying, if I understand it correctly, that you can have one expression or multiple expressions make an expression.
Yeah.
I actually heard a great example of this when someone was explaining calculus, I think. No, it was, yes, lambda calculus. And they were explaining it in good terms, in simple terms. They were saying that you can have values, right? That stands for x. You can have a, what was the other one? You can have a I can't remember what they said. But anyways, you can have a function of x, or you can have a function of x. That incorporates all types of possibilities. This part would actually be this right here, because there's this is an expression with that an expression and that an expression, which really is this. And I'm going to get to that soon, because I saw you write operators, and I want to show a comparison between operators and functions and how they're really closely related.
And you reminded me when you wrote x, we also need variables. We talked about variables last week. I'm going to make some room for variables. With a variable, you can take a value and give it a tag. We call them tags.
Yeah, tags, yeah.
You can hang a tag on it so you can reference it later.
What should we call this? X? And when are we going to assign it? Here, you assign it to something.
We'll give it a value. It goes to 14. So you're going to grab your x and get a
yank on it, and then you pull it, and then you get 14.
You get 14 back, okay? So there's variables. And you can also use variables in expressions like we talked about.
Exactly.
All right. So you'll be writing a program, and it'll be doing the sequence of steps, and you'll come upon something that you want to do a lot. Well, you don't want to just copy and paste things for a lot of reasons. So you need a way to reuse a set of expressions. That is called a function. And
should we just do R1 x and y or something?
Yeah, I think we made a function that takes the average of two numbers.
Yeah. So we could then say return x plus y divided by 2, right?
Yep. So this is just statement that's made out of variables and values, and it's a way.
So could I do a correlation now? Because we're going to jump into functions, but what I want people to realize is that functions are really no different than operators. And the reason why I want to illustrate this is because what operators do is they do something with something, right? So we could actually write plus. We see plus 2 plus 3 like that, but you could also write that as, do you want to? Okay, so
Go ahead.
you could say, you could build your own plus function, right? I mean, this looks a little stupid because we end up using the operators. But the point is, they call this the left and the right, right? Because the left side of the operator and the right side of the operator.
So here's your left.
There's your left and there's your right. And we're going to return the result of that. So these are just basically what we really need for math. So that's why they're like that. But what I'm trying to say is we can build our own operators, so to speak.
Right.
See, average could be our operator.
Yeah, you're going to have things that you want to do that there aren't built-in operators for. In fact, most of the things that you want to do, you're not going to have
something built in for
you.
Perfect.
So you can use functions to make essentially your own operators.
Okay, so should we clean the slate and start working on functions again? Okay.
Maybe we
We
should
need
have
new
2
erasers.
erasers.
That was half the time of the video right there.
That's why it takes 45 minutes.
It's the erasing. Okay, so let's talk more about functions. What did you want to cover today about functions?
Well, maybe we already covered it. Just this idea that you collect expressions inside
So like
of
average, right? Like we just showed.
function, yeah.
If we're going to do the average of things over and over and over and over, we don't want to keep doing that. We want to write it once and maintain it once, right? Because I feel like if we had code that simply said, yeah, we want the first average, right? So we'll say the first average is equal to, let's just do 2 plus 3 divided by 2. You have all these dangling, let's say, second average. We need to work on our length of our variable names, but I'm a big guy with, I like to have very descriptive variable names. But let's say we actually had, let's say, var b up here is equal to 10 or something like that. And so down here we could say b plus 3 divided by 2, right? All this code right here is being done over and over and over, right?
Right.
It's redundant.
So we could rewrite that. We could collect this, and you can see here's an x and a y and a divide by 2.
Yep, and then 2 things and divide by 2 as well.
They work.
Sorry. Yes. Thank you.
So we're going to take this expression and package it up inside of a function, give it some variable names to make it generic, and
so now we can actually write this code, and we can maintain it in one spot, right?
Yeah.
So I mean, this isn't a big example, and there's not much changing to this, but it's actually a good use. So you call it AVG, right? So we'll say AVG, and I can't remember what was here, but we'll just do something, and then we'll do another average, and we'll say B and 3. So it's the same thing, but
now he talked about maintainability. What happens if you wrote a really big, long, complicated average function, which you'll obviously never do, and you were reading in your math book about how to do an average, and you misread something.
There you go.
So you stamped out the wrong formula for average in all of these places. This happens a lot.
It does.
So by collecting that and putting it all in one place, then it's easy for you to get rid of that errant multiply and stick in a divide. And then it saves you a lot of work.
What I've noticed too is that when you start seeing patterns, you saw when I said first average, second average, when you start seeing similar code, almost like stamped out, the only thing that's different are the variables or the values. Your brain better start triggering saying, I can consolidate this into a function because I can reuse this and only have to maintain it in one area. And I mean, that's the same thing said when you start writing, the string literals everywhere. You end up having them all throughout your code, and you could have just put one variable and had it so you could change it once. And anyways, you'll get to that point, and you'll see.
A very easy way to remember that would be the dry principle.
Oh yes, dry.
See now, by the way, that's a voice of
this
Blake.
Is Blake.
So,
This is very important. D-R-Y. This stands for...
It's a good question.
I actually just said, do not repeat yourself, but
Don't.
it's just don't.
Don't.
Okay.
Don't repeat yourself.
How do you draw an apostrophe up and down?
There you go.
D, I got an R. Yeah, never mind.
You understand.
No, repeat yourself.
Hence
You
our
can't read my
45
writing
minute.
when I go that way. This is hopeless. Okay.
Now we're repeating ourselves over and over.
So you will hear people say, write dry code, or that's not very dry. That's because it's not that it's wet, like there's water coming out. It's just...
it's wet for me repeating the same
It's
thing
just
over and over and
repeating,
spitting
so-
all over it. That's
it's not dry. Okay, so the function horse is dead.
Okay, yep, function horse is dead. But let's talk about, because last week, after we got done with the video, we kind of chuckled to ourselves because I am huge on putting var
Oh yes,
in front of everything.
I was going to point that out. You saw him write var there. We didn't talk about that last week.
But we need to talk about it.
So let's tell a story.
Okay.
Once upon a time, I wrote a program, and my program was this big. And it was so simple that I only needed to remember about 2 or 3 things, and I called them A and B.
Right.
And then the program grew. It wasn't that big anymore. It got this big, and now I had to remember more stuff, C, D, E, and F. And then I got confused with the letters, so I started giving them actual names like sum and name. And then the program got even bigger. And then I found that I had 2 things that I wanted to call names. So I have a name and then a name 1 and then a name 3.
And you forgot about name 2.
Oh, yeah, of course, name.
And you didn't know that though, because it's so big you didn't even know that you forgot name.
And then I got down here on my program and I'm like, okay, now I need that name. Shoot, which name was it? So thankfully our programming forefathers invented this concept of scope, where inside of our program we can actually draw little barriers around our variables and keep them separate from each other. So now, when I'm in this part of my program, I don't need to call it name 3 because the program can only see one variable named name here. So let me just get rid of all of that. And now, I have 4 names in my program, but they're not going to cross-contaminate each other because they're scoped.
Now with this scope, which is great about this is, what he's diagrammed here is, if you're in this, executing in this scope, right, you could see name, right, and only this name, but you could see one more variable, right? And that's what I want to talk about. We have F dangling out there. And let's write another one. And you could even, let's just do G. Do we have G? Yeah, that's good. So now, name can actually see in its execution, it can see name, it can see F, and it can see G. In this section, it can see name, D, E, F, and G.
And in here, you can see this name,
Yep.
C, sum, B, A, and F and G.
Correct.
You can see from your scope going out.
To the bigger scope. The other thing to keep note is sum cannot see name in here.
Right.
Because if this was a function, it wouldn't be able to get into there because it's protected by that scope.
Yeah, this line here is a one-way mirror. Or do they call it?
Yeah, how would you say that? Anyways,
anyway,
you can't see in, but we can see out.
You can, yeah, exactly. So this is like, no, you can't do that. That's not allowed. But then you can get out to see there.
It's highly reflective barrier on the outside there.
Yeah, it's a pretty beautiful thing.
So how do we describe function scope in JavaScript?
How do we describe scope in JavaScript?
I think I gave that away. Let's ask the question one more time.
How do you specify scope in JavaScript? Man, do we have any kind of box that we can use to reuse stuff?
I think they're called functions.
Yes, a function.
Functions, that's right.
Okay, well, before I go any further, because doing this is really going against my grain, we started out doing things like this. I think we explained, it was in another video. A really important thing, sorry, to know in JavaScript is that a function is a value. So we're going to tell you that it's good practice and something you should pretty much do all the time unless you know what you're doing and you have a good reason to, instead of write functions this way, we're going to do this. Var greeting equals function. So this is going to make a new function value and stick it in here in greeting.
And the reason why we like this is because it's declarative, saying that it kind of gets people in the mindset that functions are variables, they're values.
They're values.
And so we can save these values to any variable and then use them later.
So by doing this, this variable, to invoke this function, you can just,
there it is.
Just like that. And I could come along later and change what that tag is essentially and do a lot of cool stuff. So
now I'm going to throw, let's see if you can figure something out here. Now use that to illustrate scope.
Alright, so our greeting function, I'm going to invent a function called out that you can pretend just spits out something. Out. Hi. Plus name. So this name, remember we can look out. We're going to hit here and say, do I have a name in my function scope?
Yeah, so that's what the interpreter does, is checks this first.
Do I have a name here? No.
Nope.
So we're going to go out here to the next outer scope and we'll find this one. So then what we'll get out is, hi, Jared.
So here I have a question. This is where it gets a little tricky. If someone were to come in here and say var name and not assign it to anything, what happens?
That's an excellent question.
This will be undefined.
This name is undefined.
Yes, this one is. And that would it actually be undefined here because it checks and says, yeah, there was a local variable declared. It's currently undefined, but it has been declared. And it will not find that.
So when you're dealing with scope, the interpreter is going to look for the closest one it can find and use it.
Yep.
This is not technically a collision, but it's not technically a good idea either.
Correct.
But
it's just good to know how it works, because you see code that's like that.
You need to know that. Okay, so we'll get rid of that. Okay, we'll do one more thing. This will be pretty obvious.
Yeah, that's good.
I'm going to accept a name parameter, and when I invoke it, say greeting Blake. Now this Blake will get stuck onto this name, which lives inside this scope, so that's what's going to get put out there.
So you can see this. This is actually where, you know, you're talking about how you had name, name2, name1. This is why functions are great, is because really when you declare arguments or parameters, what you're really doing is saying var name at the top of the function.
Right.
And whatever's passed in, it fills that variable with that.
Right.
So
let's talk about this keyword var here. What is var all about? In our video last week, we showed you that you could just make variables willy-nilly without the var. But the var actually means something very important.
yeah, so if you did that, it'd still work currently.
You'd still have a variable named name, and you still have a variable named greeting. The key, though, is to understand where the scoping works. If you declare a variable without var, JavaScript puts it in the global scope, which means it is accessible from everywhere.
Yeah, so even if
it's the same as saying window dot.
It is.
Or it's the same
or
as
global,
saying
whatever the global object
dot,
is.
yeah.
If you're in a browser, the global object, global scope, has a name and it's window.
And so you are gonna actually. The problem is, let's say you did variable a in here equals 0. By doing that, causes a problem, because remember the interpreter comes and says, oh, he didn't declare a var. He must have meant
global scope.
He must have meant to put it out there.
Yeah.
So you know what's interesting is this a doesn't even get assigned to the global scope until it's executed once, and that's where it gets really hard to find out where your bug is. So what our rule of thumb is,
Always say var.
Always say var, because even if you're out on the global scope, like the window scope, you've got your var there, and it puts it on in the global scope, and you're safe.
Exactly. So just point this out one more time. We'll fix our vars.
But var stands for variable. So
yeah, variable. It's easy. If we say var a, this var means this a belongs to this scope.
Yep.
So a, if I try to access a here, it'll be undefined.
Yep.
If I take off the var, I will be able to access a. Now, that might seem like a really convenient feature. It's not.
Don't do it.
Don't do it. Never use the global scope unless you have to.
Why?
Always use var.
That's a good question.
That's an excellent question.
When do I use global scope? The only time I've ever used global scope is when I'm building a library that someone needs to access. And that's it.
And these libraries never really hold values or anything. You don't care, they don't have state that you care about.
Right, right.
It's always just utilities, tools, and things that do stuff, big stuff. I'd say the biggest reason is that it's almost impossible to find where you've messed up that variable.
Yeah.
When you use the variable later, if it wasn't scoped properly, you're going to be overwriting variables that you'll write in bugs that will be impossible to find.
And you don't know why it was Jared one time and Blake another time, or 0 for that matter. You don't even know how it got its value. So
yeah. So just always use var.
So I think are we wrapped up on
I
that?
think that's pretty good. That
So,
was record time.
That was record time. So the point of this is functions are awesome because they consolidate reusable code, but they also do something great for JavaScript, and is that scoping. So that allows us to isolate variables through the process of making functions.
Oh, we should say one more thing, just in case you already know C or C++ or most any other C-like language. JavaScript scoping is different.
Yeah.
If you don't know what I'm talking about, you can forget about it. But JavaScript does not use block scope. Block scope. JavaScript uses function scope.
Correct.
And
that's pretty much it. So look up the difference. I bet you could Wikipedia that and say, what's the difference between block and function scope? And Stack Overflow will have you answered within minutes.
Yeah, probably an answer that Blake knows.
yeah, exactly. All right, well, thanks for watching.
All right.
And
see ya.
join us for our next one.